Newton's laws of motion. Consider a book placed on top of a table. The book will remain on top of the table except someone comes to remove the book. Also, consider a vehicle that is moving with uniform motion on a straight road. The vehicle will continue to move on that straight path until the brakes are applied. In both cases, an external agent has helped to change the state of the objects. This is known as inertia, and it is the tendency of an object to remain in its state of rest or in uniform motion. Newton's first law of motion is also known as the law of inertia, and it states that an object will continue to be in a state of rest or uniform motion along a straight line except it is acted upon by an external force. Newton's second law of motion. Newton's second law of motion states that the rate of change of linear momentum is directly proportional to the applied force and takes place in the direction of the force. So we can say that force is proportional to change in momentum all over time. In symbols, F is proportional to mv minus mu all over t. By factoring out m, have F is proportional to m into v minus u all over t. But we know that A is equal to v minus u all over t. Therefore, F is proportional to ma. Writing this mathematically, F is equal to kma. Now, the unit of force is the Newton, the unit of mass is the kilogram, and the unit of acceleration is the meters per second squared. So, the value of k is equal to 1. This is because a force of 1 Newton will cause a mass of 1 kilogram to accelerate by 1 meters per second squared. Therefore, F is equal to ma. F is also equal to m into v minus u all over t. Applications of Newton's second law of motion. One, we have momentum. Momentum is defined as the product of the mass of the body times the velocity of that body. So the symbol for momentum is P, so we say P is equal to mv. Next is impulse. Recall that we said that F is equal to mv minus mu all over t. So when you cross multiply, we're going to have Ft is equal to mv minus mu. So Ft is equal to I, which is the impulse. I is the impulse, so it's equal to Ft. So from here, we can say that change in momentum mv minus mu is also equal to impulse.
So impulse is equal to change in momentum. So impulse is defined as the product of the applied force and the instantaneous time of the impact of the applied force.